So our presenter today is Kevin Carrick. Kevin is a software engineering manager with Avnet. He's a computer engineer by degree, technical marketing manager by day, and an embedded software programming addict from an impressionable age, which has turned into a mostly healthy fascination with FPGA and other hardware craft over the past 10 years at Avnet. So Kevin has a really cool project for you today, and I'm excited to introduce him. Kevin?
Hi, Monica. Can you hear me?
I can hear you, yep.
Okay, great. Well, thank you for having me on today. I'm really excited to share with everybody some of our latest developments around Azure Sphere. I know we've kicked off the Secure Everything contest through our Hackster friends, and we're really excited about everything that's going on with the design contests. And I just want to share a few things for with our audience today, hopefully get some more people excited about what we have going on, and get everybody engaged with this really excellent opportunity that we have with Azure Sphere. So I'll go ahead and I'll get started. My name is Kevin Carrick. I work with Avnet, and we're an exclusive distributor for the current Azure Sphere devices that are available on the market. And I'd like to talk a little bit about what that is. So in order to talk about that, let's talk a little bit about why security is important. So this is a unique instance. Back in 2016, there was a botnet attack, and this is the first time on the first day of the botnet attack was reported on October 21st in the New York Times. It was in the technology section of the New York Times, but interestingly enough, on the next day, October 22nd, and actually the same botnet story showed up inside the politics section, and how this evolved into an everyday discussion amongst a larger audience about, you know, whether or not we can secure our infrastructure against devices that that are just open and available for hackers to break in, either brick the product or, you know, hijack those devices and use them as part of botnets to take down critical infrastructure. So this is a really interesting thing. You can look into a little bit more, but what Microsoft set out to do is they set out a long time ago to look at what it would take to secure devices. And as part of this research team, they came up with this idea of these 7 properties of highly secured systems. And this is a white paper that Microsoft publishes. I highly suggest you take a look at it. But the idea is that if you can cover these 7 different areas, you can provide a great deal of security in your device, so that if any one area becomes compromised, you can always get back to a known good state. So that, first of all, for secure devices, you really need a hardware root of trust. And so that uniquely identifies your device and helps your device guarantee software integrity on a secured piece of hardware. That's the idea. Next one is defense in depth. If any one of your security mechanisms on your device is defeated, can you protect the remainder of the system and get back to a known good state? The next one is a small trusted computing device. So the idea is to reduce the amount of attack surface in your device in order to eliminate as many bugs as possible from other code that you're working with. And the next one is dynamic compartments. Then your device's security protections improve after it's been deployed. So the idea here is that, you know, if you have different subsystems on your device, you could update any one of those other subsystems independently from the other ones after you've deployed it out to the field through over-the-air updates. Next one is pretty important for what we're doing with IoT, is certificate-based authentication. So a lot of, in the past, you know, you may have used passwords to authenticate, or you may have used connection strings with tokens. This is a lot more secure because it uses industry standard methods for exchanging security certificates in order to encrypt your communications. So then the next one is failure reporting. Does your device report back about failures and anomalies? So this can help analyze and come up with countermeasures for emerging threats like the botnet attack that we talked about on the previous slide. And then finally, one of my favorite ones is renewable security. So can your device's software update automatically so that if any one piece of it does become compromised or there's a threat identified, can you update your devices through over-the-air updates quickly in order to get them up to the latest patches in order to mitigate or avoid any threats that may be coming out. So the solution that we have today with Azure Sphere, this implements 3 different components that basically embody those 7 properties of highly secured systems. So on the previous slide, you saw a bunch of different symbols. Each of these 3 different components comprises 1 or more of those 7 different properties. So Azure Sphere is really a secured MCU that contains that hardware root of trust. So there's the hardware root of trust right there. And then you have a secured operating system. And so the idea here is that Microsoft has created a secured operating system. It's based on the Linux kernel, but they've greatly reduced the size of that kernel and the amount of code that's inside of it in order to help reduce the attack surface of that operating system, so that it really only provides the minimum amount of functionality that's needed to support IoT applications. And then finally, it comes with a cloud service. So the idea behind the cloud service, not only does it provide secured updates for the operating system, but you can also securely deploy over-the-air updates for your own user space application that's running on this board as well. So very, very interesting that you have all 3 of these properties, all 3 of these different aspects of this chip are built into the chip, and they come as one single package. So you can't get these a la carte. You can't just get the MCU. It's bundled together with the secured operating system and the cloud service altogether. So that's what we're talking about here today. We're talking about the MT3620. That's the Azure Sphere chip that we have today. It comes with its ongoing Azure Sphere security services, and it also has an Azure Sphere IoT operating system, which has ongoing device updates. So we're going to dive in a little bit deeper on how you can take advantage of this, but this is a very high value and cost-effective solution that is secured by Microsoft based upon their research in the 7 properties of highly secured systems. Okay, so let's take a look a little bit further inside of the device. So how do you create a secured foundation for intelligent edge devices? Well, it starts by using these security technology, and I want to focus on this a little bit here. You see inside of this diagram these on-chip firewalls, and what this enables the chip to do is for each of these different subsystems inside of the chip, if any one of those subsystems should happen to become compromised, this chip operates on the principle of least privilege, so that each chip has to come up and has to negotiate with the security subsystem what sort of access it has, so that way, if let's say the Cortex-A device becomes compromised, it doesn't have the ability to go in and compromise one of these other components outside of the access that it has been granted by the security subsystem. So that helps reduce the amount that any sort of vulnerability could spread to any other portion of the chip if one section should be compromised. And the other key part is this Pluton security subsystem. This is a subsystem that's responsible for enforcing the security policy on the chip, which basically means that any piece of code that executes in any other portion of the chip has to be a signed piece of software, and that security signature has to be authenticated before the chip loads that software and begins execution. So that's a lot of capability built into the chip. It's also an embedded processor, so you also get this multiplexed I/O. So for those of us who have been working with embedded systems, a lot of these interfaces will seem very familiar to us. We have general purpose I/O that we have the ability to interact with hardware. PWM, that's used for controlling motors, time domain multiplexing, and we also have I2S for audio interface. The UARTs, there's a number of peripherals that you can plug into the device that communicate over UART, so that gives it a lot of flexibility. I2C is a very simple serial protocol that allows you to hang multiple devices off of a single serial bus. So that's very useful for adding lots of peripherals onto your system that can communicate over a low speed interface. And then there's a serial peripheral interface, and a lot of these things we'll talk about when we get into the demo. Okay, so let's talk about the different Sphere products that Avnet has available today. So we have an exclusive arrangement for distributing the Sphere chip. So if you are working on an application where you're making more than 50,000 units per year, this would definitely be something that you would take a look at, where you could do your own chip down design. But since that's, involves some engineering NRE to design your own board, what you might want to consider is using an off-the-shelf module. So we also have these modules that are available, and I'll talk a little bit further about those today, because that's what we have available on our starter kit. But if you're manufacturing anything less than 100,000 units per year, I definitely recommend taking a good look at the modules, because we have modules, and I'll get into this a little bit further later on, but the modules have certification, and that's like a huge value. You can save thousands, if not tens of thousands of dollars on certification costs by reusing the certification that we've already done on our modules. And with any module, you're going to want some sort of development kit in order to get started on it to prove out your design. And we have that available as well. So we have this Avnet Starter Kit that we've created. It has the same module that you see here. It's put down in the corner of the board. And I'll talk a little bit further about what's available on this board, but it's at a very low cost price of $75. And currently, we're running a design contest through Hackster, where you can get one of these boards available for free if you qualify to participate in the design contest. So I definitely recommend checking that out. I'll show the website a little bit later on for the Secure Everything design contest, and you can hopefully get a hold of a free development board to try this out on your own. Okay, so let's talk a little bit about some of the other things that Avnet does. So you may have heard of Avnet before. We're traditionally known as an electronic components distributor, but we have so much more capability in-house that I kind of want to raise some awareness around. So for Azure Sphere, we do provide technical documentation for that. That's available at request and from download from our product website for our starter kit. We also offer design assistance. So we have blogs that are available to help people that are designing their devices. If you require much more technical assistance, we also have engineering customization services available as well. We can provide you pricing and availability for components, not just Azure Sphere. We can also help you out with a proof of concept development for your IoT design, and also help you out with your hardware design through our development kits. We also have manufacturing and integration services as well. Sphere development kits, I'll talk about a little bit more about that later. Sphere modules, cloud and digital services through our IoT Connect offering. We also have supply chain services and logistics. And we also have a technical community. So Element 14 and Hackster.io, they're all underneath the Avnet umbrella today. Those are really great environments for you to go and immerse yourself into the technical communities and learn a lot about these emerging technologies. And then we also offer technical boot camps and training that's available globally. So I highly recommend checking it out if you're interested in learning more. I'll talk a little bit more about some of the other resources that we have specific to Azure Sphere and where you can go to learn more information. Okay, so let's talk about the Avnet Sphere module. So why would you want to design with the Avnet Sphere module? Well, first of all, it's a very small module that doesn't take up a whole lot of room. It's 33 millimeters by 22 millimeters, so a very compact design. The main features of that MT3620 device, we've pinned out to this postage stamp size device. So each of these little solder cups around the postage stamps, those are separate IOs that you can solder down to the board. And we're going to offer two off-the-shelf versions. So we're going to have a low-cost onboard chip antenna version, and we'll also have a high-performance version that has an external antenna. So here's those two different versions that I was talking about. So the one that comes on the starter kit is the chip antenna version that you see up here in the right-hand corner. And then we also have a footprint-compatible U.FL version where it offers us main antenna and a diversity antenna for the Wi-Fi interface. So the idea behind using this one is if you have some sort of metal enclosure, you could drill a hole in the metal enclosure and route your antennas externally and gain access to Wi-Fi that way. And since it has the diversity, it has the potential for better wireless performance as well. So this has been available since earlier in 2019. So if you're looking for more information, be sure to check out the website or contact your local Avnet sales team for additional information. And the other thing I want to highlight is that this module will be regulatory certified for FCC, IC, and CE. There's a little bit more further detail on the module certification. So for the different modules, we have completed our FCC and CE certifications, and we're also looking at rolling out additional certifications in various countries around the world. So the advantage to this is that if you're designing your own product, you can save some substantial costs by re-leveraging our certification on our module for your end product design. And that can save you, as I mentioned, thousands, if not tens of thousands of dollars worth of regulatory testing and paperwork. All right, so let's talk a little bit about a customer success story involving our Azure Sphere design-in module. So Microsoft brought an opportunity to us a while back. They had a customer that needed to IoT enable some of their machines. And so what Avnet did is we used our module and we developed a board that this module would mount onto called the Guardian module. And this module will be available here shortly. We can share some more information on that in a few more weeks. But the idea behind that is that it gives you a board that you can put down into an end piece of equipment and use that to capture some telemetry information. So Starbucks was looking to capture some telemetry information off of some equipment that they had. Once Avnet was engaged, we helped them run a pilot program with that hardware, and we also completed that Guardian design, and that was something that was done by an internal Avnet Design Services group. So finally, in order to scale things up for Starbucks, we also built a number of different modules using our Avnet manufacturing services, and we were able to help get this into a position where it can scale across 30,000 stores worldwide. And so for those of you that are looking for more information on this, there's a press release that was done around the Starbucks opportunity with Microsoft. And you can use that QR code or the link to explore that further if you're interested. All right, so let's talk about the Avnet Sphere Starter Kit. This is the starter kit that I'm going to be showing in my demo today. So it comes with the Azure Sphere module that we had discussed earlier. That's this one down here in the lower left-hand corner of the board. And then it also has a number of different peripherals on there, and it has pretty much everything you need to get started doing some software development. On board, it has the FTDI USB to serial bridge, and that gives you a service UART, a debug UART, a recovery UART, and a software-defined JTAG interface. And that's what Visual Studio uses as part of the development cockpit that I'll show you later on. It has a number of onboard LEDs and switches. So there's reset switch, some user switches. There's some LEDs to indicate status, including power, USB activity. There's application status LED, a Wi-Fi status LED, and then there's a tricolor RGB user LED that you can use to indicate different states of the board as well. So that's really useful. It's available today for $75 US, but as I mentioned, I'll try to get the link up here later. There's a number of kits that are being given away around the world. I think that we covered most of the countries today, and you can go on to our website and see if you qualify for one of those free kits if you're interested in getting started in one of the design contests. Okay, so I'd like to talk about one of the most compelling things for this starter kit. So that's, we've added on these click sites, and what the click sites do is they enable these microelectronica click modules to be connected up to our board. So when I checked on these earlier this month, microelectronica had over 620 different click modules available, and they're adding about 3 new click boards per week. So they range in all sorts of different sensors and actuators and indicators, There's lots of different radio modules that they have as well. So those are really interesting to plug in, and I actually use them for prototyping up my demo application here. There's a few other connectors available on the board as well. So there's these Grove connectors, so you can hook up I2C Grove modules. There's also an OLED display connector that you could use to hook up an OLED display, and I'll show how that's done here later on. And it's just a lot of capability that you can use to expand out your board. So if you think about it, since we have 2 click sites on the board, if you had over 600 modules over 600 modules and 2 click sites, if you did the different combinations of that, that's over 360,000 different combinations of hardware that you could prototype with just 2 click sites on a board. So here's an example that I put together at the suggestion of Monica over at Hackster. So she had a suggestion for doing a flame detection, and I took that a little bit further by hooking up an alarm to the flame detector. And I did that by using these microelectronica click modules. So I have a flame click that I've added onto the board, and then I also have a relay click that I've plugged into my board. And then I also have OLED that I've connected up for doing some status. These OLEDs are pretty inexpensive. You can find them from multiple sources. They're somewhere around $7 to $8 in that range. So kind of dive in a little bit deeper on what I've done for this design. The reason why I chose the relay click is this allows me to control from a 3.3 volt logic level, some more heavier duty equipment. So I'm controlling 12 volts through the relay connections here to control my alarm audio indicator and then my alarm visual indicator. But the most interesting part, I think, is this flame sensor. And so this flame click that Microelectronica came up with, this is pretty flexible in that it has an onboard analog comparator that you can use this potentiometer to set the threshold value. And then that comparator is hooked up to the interrupt line here, and that provides an interrupt signal back to your processor. So you could use it in a very simple digital on-off state if you wanted to. What they've also done is they've also connected up the analog output of the flame sensor up to this analog pin. And then this analog pin is hooked up to one of the ADC channels on the Azure Sphere device. So you could also independently monitor the actual IR detection level on that device, and you could dynamically set your own threshold. And I'll talk a little bit more about that in the application as well. So lots of capability through these little click modules. Talk a little bit in summary here on the starter kit. So it has everything you need in order to get started with software development. It has an onboard 5 volt to 3.3 volt buck regulator, so you can power this off of a USB connector. And it has a bunch of user LEDs plus 4 status LEDs, so you can use that to help debug your application or use that to also interact with your end user. It has reset button, A and B user button switches that you can use to control your board. It has 3 different onboard sensors. It has I believe it's a pressure sensor and a 3D accelerometer, and there's also an ambient light sensor. So even without clickboards, you still have a lot of sensing capability with this board to get started and experimenting with an IoT application. Also has those 2 click sockets with over 620 different clickboards out there. There's a lot of different combinations of hardware that you can do. I'll try to remember this, but if I forget, Monica, maybe you can help me remember. We also have a click library up on GitHub with some example code for some different click modules, and I was actually able to leverage that for this this burn-around application that I'm showing. So lots of value that we've put together around click modules that hopefully folks in the audience can leverage for your own design. We also have that Grove sensor connector on it, and there's also a battery connector as well. So if you wanted to connect up either an external power source, or if you wanted to also battery back up the real-time clock on the chip, there's some little connector points in order to do that. So $75 US. You can find the boards at the link here. At the end, I'll try to throw up a link to show you where to go to get your free starter kit if you're going to participate in one of the design contests. Okay, so that takes us to the live demo. So let me go ahead and I'll close out these right here. And I'll switch over to my design tool. So let's start in Visual Studio here. So let's go inside of Visual Studio. And then if I go into my Blinky application here, I'll just show you really quick. This would be like the first step to getting your tools up and running and just making sure that you can connect up to a board externally. So I'm going to take one of my Azure Sphere boards, and then I'm going to connect into that. And then I'm just gonna, there's a very simple application. All it does is it just turns a GPIO on and off, and that is connected up to an LED. But here I can launch my GDB debugger. And so what this will do is it'll make sure that I have the latest code compiled, and then it'll download that code through the USB interface onto the board and start executing that example. So I don't know if you guys can see that in the camera or not, but I have a blinking LED running on this board right here with my application. Let me see if I can stop the share here, and I'll switch over to my camera view. So right here, I have this little green LED blinking on here. So that's just a simple application that's running off of my Visual Studio environment right now. Okay, so let me go back and I'll share that desktop again. Okay, so now I can go ahead and I can stop debugging in here. And nice thing about Visual Studio is it gives you ability to remotely debug your code that's running on that embedded board. You can start and stop the code execution. You can look into different variables, values, and that'll help you debug your application as you go along. So then the next thing I'd like to show for my live demo, let's do something a little bit more advanced. So this is very simple. Blink the LED, make sure your tool set is up and running, make sure your board is working. So let's go ahead and we'll close out this example here, and we'll open up something a little bit more advanced. So while I'm waiting for Visual Studio to launch here, let me take an opportunity to show a few different things. So if you go to the secureeverything.avnet.com, this is a program that we've launched with Hackster.io and Microsoft Azure and Element 14. And here's a link on here that you can go to in order to get your own free development kit. And there's a number of different links on here that I'd like to point out. There's a Sensing the World contest for Element 14. There's a Secure Everything contest for Hackster.io. There's a virtual workshop that we've launched that'll give you some more in-depth training, and along with some hands-on labs on how to use Azure Sphere to its full potential. There's a product road test that's underway that you can participate with, Element 14. There's a number of different online resources, and then there's a place where you can go in order to stay signed up for any future events. But if you go through the online resources, one of the resources that we have available is this advanced tutorial for the Avnet Azure Sphere Starter Kit that was put together by my colleague Peter Fenn. And this is pretty comprehensive. I actually use this design as the foundation for my live demo here. If you scroll down through here, it has all the instructions that you need in order to get things up, set up and running. All the steps that you need to take to put your new board into prep debug modes where you can sideload some code onto it. But one of the most valuable things is that Peter's also released the source code for his application. So if you go click on that link here, it'll take you to the GitHub where Peter's published the example application. It consists of actually two separate applications. So there's one that runs on the M4 processor inside of the Azure Sphere. And then there's another one that runs on the A7 processor of the Azure Sphere. And so if I switch over to Visual Studio, this will hopefully give you an idea of what's going on with this. So here I have a real-time application that's running on the M4 processor. So this is in a separate project. But here you can use this to read the value from the analog digital converter that's built into the Azure Sphere chip. And this reads the data out of that flame sensor that I was pointing out on the diagram. So we can actually read in real time, we can read the value off of that device and monitor the IR value that's being reported by the flame module. So let's go ahead and let me plug in my my board here, and we can actually launch this application onto the M4 processor. So we got that running. Switch over to the GDB debugger. I can actually start running that on the M4. Okay, now that's running on the M4. Now let me go ahead and go back and I'll launch another instance of Visual Studio 2019. And then I'll load up the A7 application. So this is the A7 application. I took Peter's example and I modified that slightly to fit the burner-on application. So I'll go ahead and I'll load this up. Okay, so let's kind of explore this a little bit here. What I did for burner-on, all I did is I just modified it slightly to allow for control of the relays. So I have a timer that goes through and it checks the value of the value that's reported by the M4 for the ADC that's connected up to the flame sensor. And once that crosses a particular threshold, it will enable the visual indicator for the alarm, and it'll also cycle through the audio indicator for the alarm. So this is just a timer that's going off. Eventually I'll have this instrumented up so that way I can control this duty cycle tuning value from my IoT dashboard. But let me go ahead and I'll show how this runs first. So it's a very simple application, very simple modification that was done. I can go ahead and I can launch that remotely here. So let me get this up and running, and then I'll switch over to my webcam so you can see how this is all executing here locally. Okay, so you can see my application's up and running. I'm sending some telemetry data up to IoT Connect. So speaking of IoT, I'm sending data up to IoT Central. So speaking of IoT Central, let me go ahead and show that off here really quick. So inside of IoT Central, I have a dashboard that I've set up here. So I can go in here and I can see the telemetry information that's coming from my device. So here I have some data that's being published. This is just now coming across since I started up my application here a few seconds ago. The other thing that's interesting, not only can you visualize the data, this one here is the flame IR intensity value. We'll get back to that one here in a few seconds. You can also control the settings as well. So I'll come back to this and I'll show how you can use these settings in order to change what's being shown on the OLED. You can also control some of the other things too. So this is pretty exciting. Let me switch over from my desktop over to my webcam. Okay. You see that okay on your side, Monica?
Yep, it looks great.
Okay, awesome. All right, so here I have my setup for burner on. So I have my Azure Sphere development board here. Here's the module. So that module I was showing you in the slides, that one just didn't have this can top on top. It was actually showing you the guts of what's inside. But when you get the module in the starter kit, it'll look a lot like this one does here. I've added on an OLED display. So this is that low-cost OLED display I mentioned. And then I also have the flame click added onto it. And then I also have the relay click added onto it. And so the flame click, it'll enable me to sense when there's a flame present by monitoring that ADC value from the real-time core on the device. And then I also use the relays to control these two devices externally. I have an audio indicator here, which is like a klaxon style siren. And then I also have this flashing hazard lamp as well. So I'm just powering off of this power brick right here. It's providing 12 volts, and then I have a 5-volt adapter, which I can use to disconnect it from my debug port and run it autonomously. So other thing that's kind of interesting about this, when you load up that application, you can use the user buttons to cycle through the different displays on here. So here you can see I have it hooked up to my Wi-Fi. You can see the different values that are being reported by the different sensors as you cycle through it. This one here, I'll come back to it later. This one's showing the cloud twin status. So that's kind of interesting. Hopefully if we have enough time, we can show that off. But let's get to the exciting part here. Let's and for those of you that are wearing headphones, you might want to turn the volume down. This can get kind of loud. At least it's pretty loud here for me. So I got my trusty Zippo lighter here, which I've So you can see when you apply the flame in front of the IR sensor, it does a pretty good job of picking up that value. And then once we see that that value has exceeded the threshold value, then we can trigger the alarm conditions and let people know that there's a fire that either needs to be put out, or if it's a little bit out of control, they need to get into a safer situation. So let me go ahead and I'll flip back over to my desktop view, and we'll explore a little bit further into the dashboard, as that's kind of has some interesting settings to it. So if I share my desktop here and I go into my IoT Central instance, here you can see the different properties on it. And what I can do is I can actually control that RGB LED. So I can turn off the red element and I can turn on the green element. So that'll be kind of interesting. And then let me go ahead and I'll modify that OLED display. So here I can send down different character strings down to the OLED. And so let's see here, let's do hello. All right, and then when I click the update button, what this will do is it'll set those properties inside of the device twin. And then the next time my device connects up to that, what it'll do is it'll synchronize its device twin properties, and we'll see that that state has updated. So let me go ahead and I'll turn off my desktop sharing so we can kind of zoom in on what's going on with the board. So here you can see my device twin is synchronized already, and I got the hello Hackster.io message showing up on the OLED. You can see that the OLED has switched from a red state into a green state. So this is pretty interesting. I was able to do all this stuff actually with the dashboard last night by following that tutorial that Peter had posted up on Element 14. So that's incredibly useful. What I'll do is I'll take and I'll package this up and I'll put this up as a project on Hackster.io. So look forward to that coming out here pretty soon, if it's something that you're interested in replicating on your own. Let's see here. I'm trying to think if there's anything else that I'm forgetting to cover before I go back to sharing my desktop. All right, let me go back and I'll finish sharing the desktop. So just a few other things that on the website. There's the specs for the kit if you're looking to find out more details on the kit. Some more details on the module. Here's some information on the microelectronica clipboards. You can actually buy them from our Newark and Avnet e-commerce sites. There's a number of them that are posted up, listed up there for availability. Once again, there's a number of different kits that are available today, so be sure to get your free kit. And then also, I really encourage you guys, if you're not already a member, to join our Hackster.io and Element 14 communities, because there's a lot of great information that's being put out there by all sorts of community members. And anything that we put together here at Avnet, we also share that and make that available as well. So with that being said, oh, there's one other thing I wanted to point out, and I almost forgot about it. So if you look on the Avnet GitHub, one other thing that was really useful for me to put together my burner on demo is using these clipboard demos. So one of the folks on my team, his name is Jim Flynn. You may know him by B Guy on Element 14 website, but he has architected this library that can be used across a number of different platforms that incorporates a number of different click modules. And so I was able to use this library to help accelerate my burner on application development by just leveraging the code that he had already done for the flame sensor and for the relay. So not like a huge programming wizard myself. Jim had kind of already done a lot of the underlying foundational work for this, and I was just kind of able to swoop in and pluck out some of these jewels and stuff them into my Azure application. So there's this library right here. There's some instructions on how to clone that and take advantage of that. And then there's also a clipboard demos folder here. So if you're looking at just rudimentary, just making sure that that click module that you've plugged in actually does what it's supposed to and that you've got it connected properly, there's a Sphere MT3620 example library for those click modules as well. So these are standalone projects. You can pull them straight into Visual Studio and they'll tell you, whether or not that module is running so that you can experiment around with those modules and see if they're appropriate for your end application. So really great resource. I was able to take advantage of it and I was able to combine that in a modular fashion by modifying the example application that Peter had posted up in his blog post here. So great resources to get started. And little known fact, this example application that Peter had put together for the advanced tutorial, this is a really great starting point for you to start with a known working code base and launch your own design for one of the design contests. So rather than starting from scratch with Blinky LED and working your way up, you could start with something that's much more advanced and much more closer to what you're trying to do and just go in and modify a few lines of code in order to get something slightly different. And which is exactly what I did in my application. So I think that covers everything that I wanted to cover. And I think we could probably move into the Q&A session if you'd like, Monica.
Sounds good. Okay. All right. We have some really good questions that people have been asking. So,
okay, great.
So Paul asks if PWM and I2S are supported yet.
No, that's a really good question. Those are not supported from what I know, but Microsoft is providing continuous updates to that operating system, and I know those are on the roadmap. So I would look for an update here on those devices. But there's a number of other peripherals that are available on that device that could help you get started with one of the design contests in the meantime.
Great. Okay. This is more of a statement than a question, but Ronald says, not all MEKROB clipboards are ported to Visual Studio. Could you talk about that a little bit?
Yeah, so that's a really good point. Microelectronica provides example code for their click modules for a number of other different platforms. Avnet's in a really great position to provide examples for how to use some of those click modules for the Azure Sphere platform that we have. But with there being 620 different or over 620 different modules out there, it's really difficult. Like if you did the math, there's just a handful of folks on my team. It would probably take us like 5 years just to support the ones that are available today. So, I mean, that's a great opportunity for folks in the community. If anybody's interested in contributing to one of those GitHub repositories that I pointed out with the Sphere, with the Sphere example code for those click modules, we'd be more than happy to help, get that into our repository so that other community members can leverage that and take advantage of the hard work that you've done, and we can kind of all build upon each other's successes around Azure Sphere and Microelectronica click modules. So thank you. Thanks for bringing that up.
Cool. And then Veranda Verma asks about the range of sensor, which I assume is the flame sensor.
Yeah, no, that's a really good question. So I experimented around with it a little bit. I don't know the exact physics behind it. I would imagine it probably follows some sort of inverse square law for doing it. But you can see, like, if I take my flame sensor, let's see here. If I switch over to my desktop here really quick, you can kind of see, like, let's see here. Desktop there. You can see by the little red LED that's on top of the flame sensor. If I, like, I'm holding it probably about like 3 feet away. Probably about like 3 feet away from the sensor. So it can be pretty sensitive. I would suggest what my next step is before I publish this. I'm going to try to instrument up that analog to digital converter value, so that way it becomes a property that I can set via my IoT Central application. So that way you can kind of fine tune it a little bit for your specific application. I noticed when I was getting ready for the webinar, I have an east facing window here in my office. And so like as the sun was coming up, it was actually setting off the flame click threshold. So that's kind of it. It's definitely pretty sensitive. So you're gonna wanna have a dynamic threshold set on that. But that's a really excellent question.
Verender also asks if we can write the program in C#.
Yeah, so today C# is not supported. So you have to kind of think about like what we're dealing with here. This is not like a Raspberry Pi type board. This is really more tended as, if you really think about it as more of an MCU that has an advanced secured communication system bolted on top of it, that's really what this is intended for. So in order to operate within the constrained memory of the Azure Sphere devices, today they only support C programming. But that may change in the future as they, there's another interesting website that I'd like to point out. Hopefully, let me go back to sharing my desktop. This is pretty relevant to this question. I think it's really interesting. So if I go here and I Google Azure Sphere feedback, one of the top listings on here is this 63 ideas. There's 63 ideas currently. There could be more. But the idea is Microsoft's looking for feedback on how they can improve Azure Sphere. So if there is a specific feature that you're looking for, be sure to go on here and either vote for one of the existing items, or if you don't see what you're looking for on here, be sure to propose that. So that is something that's been proposed in supporting C++ and C#. So that it may be something that if Microsoft is able to support on these resource constrained devices, that may be something that comes out in the future. But another excellent question. Thank you.
Okay. So Paul asks, where in the VS project do you indicate which processor, A7 or M4, that your app is targeting?
That's a really good question. I'm not sure if I know that detail. One thing that I didn't point out that I think is important to point out though is, and this is covered in the online training. So Hackster has a technical training course workshop. So you may find details like that inside of the technical training course. I know like one of the things that I learned from watching the technical training course is there's a lot of things that are covered inside of this app manifest JSON file. And so inside of the app manifest JSON file, this basically is what tells the application, actually tells the Pluton security subsystem which resources this application should have access to. So this application has access to all these GPIOs in order to perform its function, but it doesn't have access to anything outside of those. So the idea behind that is this principle of least privilege, where if, let's say, the A7 does become compromised, that it can't go out and say toggle the GPIO that's hooked up to, say, somebody's pacemaker, for example. So having those pieces fully separated and isolated is an important aspect of the security. I don't know the exact answer to Paul's question, but if there's a space where we can post an answer, I'll do some research and post an answer up later.
Sure, yeah, the contest discussion board is a good place.
Okay, great. Thank you. Thank you, Paul.
All right, Shankar asks, once device is registered, can it be unregistered?
Yeah, that's a really good question as well. So the idea behind security for this device is that this device has one single owner. So when you get a device and you follow the instructions, what you'll be doing is you'll be claiming your Azure Sphere device to a tenant that you've created. And that tenant is basically an Azure Active Directory instance that's in your name. So then you become the owner of that device. So currently, Microsoft doesn't have the ability to migrate between tenants. So if you we're looking to transfer ownership of that device to somebody else, that's currently not in the place. But I know it's something that they're considering. So it may show up on the roadmap here pretty quickly. So just to kind of reiterate, be careful when you register your device and make sure you don't lose your Azure login that has your Azure Active Directory instance inside of it that you've claimed to your tenant.
So related question, actually from Balaji Babu, he asked, could you please tell me how to create an Azure Sphere tenant?
That's a really good question. If I don't have them handy, but Microsoft actually put together a really excellent set of instructions that you can follow that'll walk you through setting up an Azure Active Directory tenant. So my recommendation is to follow the Microsoft instructions because they're pretty good about updating those instructions anytime that they change. But I'll make a note of that so that way we post up something later on that has the link for that.
And Avinash just posted that in the chat as well, the docs from Microsoft, so you can click it there.
Oh, okay, great. Thank you very much.
Yeah, thanks, Avinash. Cool. Okay, Harold Poulter asked about adding an MCP23017 module to my project. I will have that stuff published in GitHub after I'm done. I will add it to the repo he just mentioned. I'll add it to the repo he just mentioned as soon as I can. Okay, it's not a question. Sorry.
No, that's really great. Thank you.
Awesome.
Thank you very much for contributing back. Like this, I mean, the more people that contribute back, the more, successful everybody can be with this by not having to, reinvent the wheel every single time, they want to add a new device onto it. And other people can leverage that for their design contest entries as well. And so the more people we get, participating, the more exciting that design contest will be. And I know there's some really excellent prizes that you folks at Hackster have offered up for the winners of that contest. And I'm really excited to see the results of it.
Yeah, same. Okay, a couple more questions. Mike Bernstein just asked, any support for lower or LoRaWAN connectivity?
So am I understanding that right? Like lower end connectivity? Like
LoRa or LoRaWAN.
LoRa. Oh, okay. So I don't know of any like built-in support, but I've looked into a few of the different radio interfaces. So the idea behind like a lot of the radio interface modules out there, they have modules that are sort of, I think you would call them integrated modules or smart modules, where they have their own microcontroller on them, where they're controlling the stack, and you just kind of communicate with them from another microcontroller via the UART interface. So if that was the case, and you're just sending like some AT commands or some simple instructions over UART, I think that would be possible. I haven't seen any examples of that today, but if that's something that you do end up implementing an example around and are willing to share that back with the community, we are more than happy to help integrate that back into our GitHub repository so that it becomes available for other customers. One thing that I found that is not well supported, and it comes back to the whole security model, is that if you're using a device that requires its own TCP/IP stack implementation, those are a little bit more difficult to get those integrated because of the way Azure Sphere Security is set up. So I think it's really like a case-by-case basis on what it is that you're trying to hook up in terms of a communications peripheral.
And there is a LoRa clickboard from Microelectronica, so.
Yeah, it's hard to memorize all of them because they're adding so many of them all the time. Like I saw some pretty amazing ones not too long ago. Like they have like a digital paper one to where it's
cool.
kind of like the e-reader style paper, and that was a display that they had on there. I'd never seen one of those on any other board.
Nice. Okay, so Raul just asked, can you give me some examples for the security-based projects that can be implemented using Azure Sphere?
Sorry, could you repeat that question again?
He asked about examples for security-based projects which can be implemented using Azure Sphere. So I guess that would be like the GitHub link.
Yeah, so let me see, is my desktop still sharing?
Your slides are.
Okay, good. All right, so let me, so there's a number of different examples out there. So the best place to start is from Secure Everything. So if you start from here, there's some online resources in here. So this is a really great page that has all sorts of information on the different contests, the road test, the Sensing the World Challenge, Secure Everything contest. There's a number of different blogs to get you started. Here's the technical training course. So if you're completely new and you're just kind of looking to follow along with something that somebody else has already done, this one's actually done by another peer on my team, Brian Willis. He walked through like the whole entire process of getting a board set up and getting some more advanced things set up, so and up and running on your board. There's also, oh, well, there's this webinar. That one's posted. A link to that's posted there as well. There's a number of different advanced tutorials, but in terms of security, like the security for this device is kind of already baked in. So if you're using one of the existing examples where it's connecting up to an Azure instance of something, like whether that's a IoT hub instance and you're doing your own Azure application, or if you're doing more of a software as a service type implementation with something like this IoT Central application, the security is all baked into that communication stack. So the idea is that there's a certificate-based authentication before it can even communicate with these different services. And so it's already kind of, secured from the ground up. So hopefully that answers your question. If it didn't, please let me know and I'll try to get you the answers.
Yeah, and I'll be sending out the links that we talked about today in an email after this with the recording and your slides. So.
Oh, okay, great. Thank you.
Yeah. Great. Okay. So Robert Turner asked, is there a video that demos hooking up IoT Central to a demo of the built-in sensors?
There's not. I think that is. So if you go to Secure Everything, so this is a great place to start. So if you go to Secure Everything and you go to Virtual Workshop, this course, something you normally would charge $9.99 for, but because of all the activity that's going on and due to popular demand, you can actually get this for free for a limited time. So I'd highly recommend taking this course while it's still available. But this course will actually walk you through building an application that runs on Azure Sphere that connects up to IoT Central, that provides you the telemetry information for all the sensors on the board. So like if I go back to my measurement screen here, we should have the telemetry information that we've collected from our board up in here. Let me restart this because it looks like I lost my feed coming across. Just stop this here and then I'll get this restarted. It takes a few seconds for that data to synchronize with the IoT Central application, but all the onboard, you can see the onboard sensor information, including the signal strength indicator for the Wi-Fi. All that stuff can get published up into the IoT Central, and there's a template that you can use in order to import that. And once you have that established up inside of IoT Central, you can kind of customize it and add other things on, especially through the click modules, and then also through the seed grove module if it's an I2C sensor.
Cool. Sabarnath asked, without MEKROB add-ons, is it possible to do projects easily?
Yeah, so the other thing that's great about the microelectronica modules is they do have like these little 10th inch headers on them. So you could use just jumper wires and jumper over to another board. Like one of the things that we did early on with this platform is that you can, we took a microchip power meter and we used just a set of jumper wires to connect up the RS-232 interface from the power meter up to one of the UARTs on the Azure Sphere board. And so we were able to capture the raw power measurement information off of the analog front end for the power monitor board. And then we were able to use Azure Sphere to securely transmit that information up to the cloud. So we can do power monitoring on a number of different devices that are just using regular AC power. So a lot of different flexibility, since you have those connectors on there, you can you can plug in some of those jumper wires directly into the board and prototype up your system before you commit to doing any sort of custom hardware design.
Cool. Okay. So Syed had asked in the chat if we can use Platform IO on code to program the kit, or if we have to use regular Visual Studio.
Yes, if I'm understanding the question correctly, the question is, can you use Visual Code to write the application? So my answer is, I would say I would recommend against doing that. I saw somebody post something on the forum where they said that they were able to get code to compile using another tool chain, but obviously those other tool chains aren't supported. So my recommendation is to use Visual Studio. That's the one that currently has the Azure Sphere SDK supported inside of it, and that's the one where you're going to get the best amount of support. Because if you use some other tool chain, although you might find that it actually works, it's something that's not really supported as of yet.
Cool. And so Alton Crossly asked if we can get KiCad footprints for the module.
So KiCad is not. That's a really good question. I know that there was a design that was released around the Guardian module. I don't know what footprints those were exported in, but if you're in contact with your local Avnet sales office and you contact that local FAE, and what you can do is you can actually request the design files for the starter kit board itself. And that starter kit board was designed inside of Altium, and you can actually get the design files for the starter kit board, and that would give you the footprint that you need to get started on working on your own PCB design that would accept the module footprint.
So anonymous person asked if there's any possibility to configure the device on a Windows 7 PC.
Yeah, whether or not you can actually do it or not, I'm not really sure. I know for the Visual Studio plugin for Azure Sphere SDK, it's only supported on Windows 10 today. So I don't know if it will work on Windows 7. I would guess not. I've heard other people trying to use Windows 7, despite the fact that only Windows 10 is supported, and I haven't heard of anybody having any luck. So I'd definitely recommend just using Windows 10. I've seen in the past where folks have actually run Windows 10 inside of a virtual machine and loaded up all their tools inside the virtual machine, so that way they can kind of set it aside when they go to work on another project and then pick right up where they left off on the same exact version of the tools. So that might be another option, is just run a Windows 10 virtual machine.
Cool. Okay. If anyone else has any questions, we're a couple minutes past the hour now, so we can maybe have time for one more, or if there's anything else you want to cover, Kevin?
Yeah, actually, now that you mention it, let me just kind of end with talking a little bit more about the resources that we have and kind of steering folks in the right direction. So I highly recommend evaluating Azure Sphere for securing your next design with the Avnet Starter Kit. I like to say that it's the easy button when it comes to security. Like, there's a lot of the things that we showed today in terms of security. You could certainly do it on your own using some other MCU. If you're an expert in the areas of security and embedded development and using a hardware root of trust. And what Microsoft has done is they kind of package that all up into this easy use package for software developers like me that don't really want to have to spend a whole lot of time implementing all those things and managing my own certificates and everything. Microsoft really has done a great job of taking care of all that for us, so we can focus on working on our embedded design that we're interested in. Like, I was interested in doing this burner on application that Monica had suggested. So rather than having to worry about learning how all the certificates work and what is the hardware root of trust, what does that mean, I was just able to dive right in and write some code to control the relays and read the value from the flame sensor. And now I have a fully secured solution for my fire detector. So definitely recommend checking it out. Procure an Avnet Sphere Starter Kit from Avnet. While supplies last, there's some free starter kits out there if you qualify to get one of those. If not, there's all there. We do have the starter kits available for $75 US at the link shown here. Download the Microsoft Visual Studio and set up the Azure Sphere SDK. You can use the community edition, so there's no charge there for setting that up. Definitely check out this link that I had posted and I showed earlier, the secureeverything.avnet.com. I don't know if that's something you can post into the chat easily. I don't seem to have the ability to do it from here, but that's the page where you can kind of launch into all those different other resources. So kind of treat that as your starting point for using your starter kit and learning more about the different resources that are available. I highly recommend the technical training course for Azure Sphere. That's now available for Hackster.io, and for a limited time, it's available for, there's a promotional code that'll get you access to it for free. And then once you get further into a design, definitely contact your local Avnet FAE for demos, workshops, and we have a more advanced bootcamp training as well. So there's a lot of information out there for you to digest, but lots of valuable resources to getting started with your design and completing one of these design contests. So let me go ahead and close out there. So thank you very much for having me, Monica. I really appreciate being on here. It's always a lot of fun working with the Hackster folks. And we're definitely looking forward to all of the things that come out of this Azure Sphere design contest that you guys are running.
Awesome. Thank you so much for presenting today, Kevin. And I'm really excited for this contest as well. So.
Okay. Awesome.
Yeah, great. Have a good day, everybody.
All right. Thank you.
Yeah. Bye.